Okay, in this presentation we are going to look at a quick worked example of the Poisson distribution. I won't spend that much time on this one. Just a sort of quick remark to say that the probability mass function is written below, and actually just what happens here is that this typesetting thing does not like exclamation marks, so it's actually k factorial. The number of visitors to a web server per minute follows a Poisson distribution. If the average number of visitors per minute is 4, what is the probability that there are 2 or fewer visitors in 1 minute, and there are exactly 2 visitors in 30 seconds? So just to sort of, I'll go through this one very quickly just to sort of pick out the key characteristics of it. First off, what we will do here is look at the probability mass function, which is the probability of x taking some specific value k. So x is the variable name, okay, and k is some number, so 0, 1, 2, 3, 4. Now, what we should do really is actually just specify what x is. Now, x is the number of visitors per minute, okay? That's what x is. So just a little little sentence like that, number of, and you also would sort of say that x is Poisson with m equal to 4. Okay. Now, just a quick remark here. In other videos, I actually deliberately changed notation. So m here is the Poisson mean. Okay. In other videos, I actually use mu or lambda, and I sort of deliberately mix up the notation a bit, just to keep you on your toes a bit. So here, m is the Poisson mean. Yeah, I wrote it down here. Okay. Now, so the first question we're asked is, what is the probability of x less than or equal to 2? 2 or fewer, okay? So we can break that up as follows. That is, what are the sample points that correspond to less than or equal to 2? Well, we could get 0, we could get 1, or we can get 2, okay? So if we're going to do this by using the probability mass function, by working out the calculations there. So in this case, what we have to do is calculate probability of x equal to 0, probability of x equal to 1, and probability of x equal to 2. Okay? Now, for the most part, the calculations are fairly consistent. So m here is 4. So what we have here is e to the minus 4 times 4 to the power of k divided by k factorial. Okay? And actually, just to remark that the factorial signs just get cancelled out there for some reason. I don't know why that is. Just something we have to live with. So essentially what we have to do here is 4 to the power of 0 divided by 0 factorial. That is 1, and 0 factorial is 1. So that just ends up as being e to the minus 4. 4 to the power of 1 divided by 1 factorial is 4 divided by 1. Okay. And then 4 squared divided by 2 factorial is 16 divided by 2. So we end up here with 8 to the power of e to the minus 4. Essentially, just actually really what I want to pick up on here is that there's a common term here. And if you're sort of stuck for time in an exam situation, just the approach I'm taking here of not sort of solving everything in one go helps a lot. So essentially what I have to do here is to calculate this probability of x less than or equal to 2. 1 plus 4 plus 8, that is 13, times e to the minus 4. So essentially we only have to do this calculation once, and that should work out to be 0.238 on our calculator. Okay, that's it. Now, so the second thing here is for a 30-second period. So essentially we're told that we're dealing with 4 per minute. Okay, so in this case x is something similar to this. X is the number of visitors per 30 seconds, and the expected value x is a Poisson random variable m equal to 2. Okay, essentially just a quick sort of restatement of what now x is now. Okay, because we slightly changed the definition of x because we have a slightly different specification. Okay, so I've gone out a shot there, but just something like that, another m equal to 2. Okay, so something similar here. Probability of x equal to 2, that is e to the minus 2 times 2 squared over 2 factorial. Okay, so 2 squared is 4. 2 factorial is 2. So 4 divided by 2 gives us 2. So we should end up with 0.2706. Okay, that's great. We'll leave that there. So essentially what was the key sort of thing about that? Really actually was just sort of trying to speed up your calculations, just sort of using that approach of not doing everything in one go, not doing all the calculator work, just calculate e to the minus 4 once, if you get me. Okay? Just sort of recognizing how you can break it up and speed up your calculations in an exam situation. Okay, that's grand. Let's leave that there.